All right. Good morning, everybody. Close these down. And I'll start up a new project. We're going to talk about Chapter 4 today. We're going to get through about half of it, or so, maybe a little bit more than half, because come Monday, we needed some time to talk about our pie project. Make sure we have enough pie. I'm really hungry this morning. Really could use some pie. It's the rainy weather. It does. The Ridgewood Cafe, we've got the culinary department on this campus still until it moves over to Royal Oak. On Mondays, they're going to start quick service lunches. They used to do it all the time. It was fantastic. So I'm looking forward to that come Monday. They probably sent an email about it. I don't know. I got like 3 different ones. So I don't know if they sent any to you folks. We'll talk about the start here of Chapter 4 at least. So I'm going to name this one Morning because we did Chapter 4 last night in my Tuesday night class. Right, they're ahead, so we finished all of Chapter 4. So all that's out there. We'll do some examples here this morning. If we can get the project to start. All right. There we go. Cool, I'll just get rid of some of these comments here. Again, it don't hurt anything, but it just makes it a little harder to see everything that we're doing. So all of our code's going to go inside of this public static void main string square braces args curly braces. Right? We start here. Oh, is the due date the 27th for the project one? Do I have the date wrong? Must be misremembering. This is why I put it all in D2L. It's 5 more days? Yeah, that is Monday. Okay. Yeah, they look like too long out. Yeah, so they'll be due Monday. It should be 10 a.m. before class starts, so you can go over it in class. I had 2 people on the Tuesday class email me at like 3 p.m. for various reasons and said it's not done yet. Can I turn it in later? And I had to nicely remind them, no, I can't take stuff late because I go over answers in class. Right? Like the time it's due, like 10 minutes later, I'm going to be going over it in person. So please plan accordingly for that. Yeah, September 27th, right? Maxim? That sounds right. That's Monday. Nope. 436. Sorry. Just double check, make sure D2L is right. Yeah, 27th, 10 a.m. Awesome. So we've got Chapter 4 today, and then we'll finish up come Monday, and then we'll talk about the next project. And every 2 weeks, we're going to have another project as we work through the initial portion until we hit a little bit later in the semester. Let's grab our schedule real quick. Yeah, so we're off here a little bit. I should update that. So we're doing the projects on the Mondays instead of the Wednesdays. That should be fine. Shouldn't run into any issues there. All right. All right, so we've done some basic checks inside of if statements, else if, to do, hey, is this greater than, is it less than, is it equal to, or not equal to? Right, so if we ask the user for a number, maybe, so make a scanner, in, and we'll ask them enter a number. And then we can have, we got to add our imports here. Yep, thank you, NetBeans. Add our import. Then we can have an int for we'll just the user's number. We can take the integer.parseInt. Doing the parsing this way is always easier. At least I'll say it's always easier than using the scanner nextInt. Because if you're using the scanner object to read integer values or double values, right, the enter key is actually a character. It's that \n new line character. So when it reads the numbers out and it sees an enter key, it says, oh, you're not a number, I'm going to ignore it. So then the next time you go to read text, when you get the next line, it says, oh, there's a key here up to a new line, I'll grab that. So it causes all sorts of trouble if you're mixing and matching between numeric values and strings. So it's just probably always easier to use the parsing and just grab everything as a string with next line. Not find in line, next line. Semicolon. There we go. It's way too much bright red there. Okay. So we've got a number. So some of our easy checks, right? We could say, hey, if the user's number is equal to 4, we could do something. Right? Or we could say if the user's number is not equal to 4, we could do something else. And again, they don't have to be if, else if, else if. They don't have to be that chain of mutually exclusive ones. If we just want them all to be ifs, that's fine. It's going to check each and every one of them. So it depends on if you want multiple things to be able to happen or if you want one and only one thing to be able to happen. Right? We could say if the user's number is less than 4, we could do something else. Or if the user's number is greater than or equal to 4, right? We could do other things. User's number. There we go. Again, just some basic operators. These are relational operators, right? How does one number relate to the other? So equal, not equal, less than or equal to, greater than or equal to. I mean, all different ways of relating one value to another. And these work great with numeric values. Not so good with strings, right? We don't want to use the double equals or the not equals for strings, because it's not actually going to compare the contents of the string, which will cause trouble later for you. So these are all well and good, but what if we wanted to do some additional checks? What if I wanted to say, hey, the number is greater than or equal to 4, and then it's also less than or equal to 20? Right? So we're going to introduce this idea of, these are relational operators. We'll introduce logical operators. So logical operators take two different Boolean values, a true or false, and it's going to combine them into a single one. So it's going to deal with logic, right? True and false logic. So you can use an AND. That's ampersand, ampersand is an AND. You can use pipe, pipe is an OR. The pipe is the shift backslash right over the enter key. 2 pipes. And then you also have a not. That's just a single exclamation mark. Like we have not equals is the exclamation mark equals. So just a single not here will reverse something. So the easy one, right, if you say not true, that's going to equal false. Yeah, it's the opposite. And then not false is equal to true. Right, so the nots just flip it. So if we wanted to check, hey, if they entered something, so how about we say enter your favorite color? And we'll have a string for color. Keyboard.next line. We can check, hey, if their favorite color, if your color, scroll that down a little more. And again, usually we check ignoring case. It's just easier when we're dealing with users' input. So if it equals blue, we want to do something. Or we could say, hey, if it's not equal to blue, do something. Right, so the not's really useful when we're like checking, is it not this? Because otherwise we'd have to do all of our logic inside the else, which is a choice. But if we specifically want, hey, it's not this value, I want to do something, it works out well for you. We'll just tell them you're wrong. And blue is clearly the best color. So, all right, so that's the not, right? It flips them. With ands, I always like to give the example of McDonald's. If you go to McDonald's and they say, do you want a burger and fries? You're of course going to say, no, that's disgusting, because McDonald's fries are awful, right? There's no flavor there. There's like a ton of salt and no flavor, no real potato there. They're awful. So if they say a burger and fries, obviously it's no. The fries are awful. Now, if they say, do you want a burger or fries? We'll say, yeah. I mean, the quarter pounder with cheese, it's supposedly cooked fresh. It's not just kept in one of those little warming ovens for way longer than it should be and then served to you, right? They promise it's cooked fresh. If you know otherwise, don't tell me. I want to believe, okay? I want to believe what they're selling, okay? So a burger or fries, sure. Yeah, I'd eat one of those burgers, right? And actually, the Big Mac with the Big Mac sauce, still, I don't know, it's amazing. Despite you can make it at home too, but something's good about that. So with an and, both sides have to be true for the whole thing to be true. So if we say true and true, the whole thing is true. If we say true and false, right, do you want the burger, but you don't want the fries, then the whole thing is false. Oh my goodness, I can't find my keys. If one of them, right, if it's false and true, right, if either side is false, the whole thing's false. And if both are false, the whole thing's false. So the only way you get a true with anding is if both sides are true, right? If you go to Wendy's, yeah, their fries are decent. They got some good potatoes, right? I don't know what's wrong with McDonald's. And they even put milk in theirs too, which is the weirdest thing. So like if you have a milk intolerance, you don't eat McDonald's fries. I don't know who thought that was a good idea, but I'm sure they did some sort of focus group. So that's anding. For oring, right, this is and, this is our or. If either one is true, the whole thing is true. So true or true, true, right? Great. You want one or the other? Yeah, sure, we'll take it. True or false, the whole thing is true. Right? If you want just one of the two options, sure. And if the first one's false but the second one's true, great, the whole thing's true. The only time it's false is if they're both false. So false or false, the whole thing's false. Right? If either one of them is true or both of them is true, the whole thing's true for our ors. So this lets us do some better checks, right? So we can say, hey, enter a number between 1 and 100. I keep going down to the bottom of the screen. I'm sorry. I'll put a bunch of more new lines in for you. It's a little easier to see when it's near the top, right? And then we'll get their number. So this is, what do we have here? We had user's number. We'll overwrite that again. So user's number, integer.parseInt, keyboard.nextLine. And then we can check. We can say, hey, if the user's number is less than 1 or the user's number is greater than 100. We're going to tell them, it said 1 to 100, dummy. Right, we can check. Hey, if either one of these is true, they did a bad thing. We're no good. Now, this isn't all that useful because we're not asking them to do it again. Right? I mean, we could, but then we'd have to check it again, and check it again, and check it again. And hopefully someone just clicked in your head, if we're doing something over and over and over again, why not make it a while loop? Right? So instead of saying if, we can say, hey, while their number is less than 1 or greater than 100, ask them again. Right? I don't know, maybe we'll keep the prompt again. Right? And we're going to check it again. So we can do a validation with our loop here. Right? We're saying, hey, if you give me an invalid value, you go in the loop, and you don't get out of the loop until you give me a valid value. Because if the number is not less than 1, right, then this is false. And if it's not more than 100, this one's false. False or false, the whole thing is false. And if a while loop gets a false, it doesn't run. And it only runs as long as it's true. So it's true if it's too small, or it's true if it's too big. Either side. That part makes sense? So the weird thing with these logical operators is you can essentially write them any way you want. Some ways generally are more clear than others, but it'll work. If you wanted to, we could do the whole thing again. But we could say, all right, if it is greater than or equal to 1, and it's less than or equal to 100, take the whole thing in parentheses, right? Force our order of operations, and then say not. And we can say, hey, these are the valid values, this and this. They both have to be true for it to be valid. So it's only true if it's valid, and then we say not that, the opposite. So if it's not greater than or equal to 1, or it's not less than or equal to 100, right? If either side of those is false, the whole thing is false. So a value of 0, it's not greater than or equal to 1. It is less than or equal to 100. So we have a false and a true. And remember, if either side is false, the whole thing is false when you and. So we get a false result, and then we say not that. So not false would be true, and our while loop would run. So generally, if you can help it, it's easier to not have a not. Not. That was not intended. Right? Because it's less thinking to just say, oh, okay, this or this, rather than this and this, not that. Right? They both work. They do the exact same thing. Right? Just one's a little bit easier to follow. Okay? I'll call this the hard way. Okay, so we can do those sort of validation loops. Those are awesome. Now we could do the same thing like with strings here. Right? Let's ask them for. We'll say, instead of a favorite color, how about enter a primary color? Right, your primary colors, your red, your blue, your yellow. Right, it's got to be one of those. So we're going to check. We're going to have a loop here. We'll say, all right, if it's not blue and it's not yellow and it's not red. Oops, red. So if it is one of those, the equals will be true, and we're saying not that. So one of these portions will be false if it is blue, or if it's yellow, or if it's red. Right, because we're anding them all together here. Because we need this to be true for the while loop to run. Now, we could reverse the whole thing, right? And we could say, hey, it's blue, or it's yellow, or it's red, not that. And have a single not. Again, maybe that's almost the same, right? So this is a validation loop with strings. And do you want to see it the other way? All right, we can do it the other way. So we'll do it one more time. But we should actually do something inside the loop and ask them again, right? Make sure it's not an infinite loop. Like maybe not you're wrong, but like that's not a primary color. Might be a better, I don't know, tell them something. Primary colors are red, blue, and yellow. Is that a more helpful error, maybe? All right. Yeah. Again, we want to be helpful for our users. All right. So if we want to do it the opposite way, we can say, okay, if it is blue, or if it is yellow, or if it is red, right, the whole thing. So notice it highlights the parentheses, so I can see this ending parenthesis matches this one. So yes, it's blue, or yes, it's yellow, or yes, it's red. The whole thing there, not. Right? Because if it is one of those, I'll get true, and I'll say not true is false, and the loop doesn't need to run. But if none of those are true, false or false or false, the whole thing's false, and I say not false, it's true, and the loop runs. Again, either way, whatever is going to make sense for you reading it. I like saying it's not this, and it's not this, and it's not this. But again, I'm just partial to that. So they'll get the same job done with our validation loops. Okay, so we could do more things once we add these logical operators in our if, else if statements, or in a loop, right? Any way we can add this Boolean logic, the logical operators, and combine multiple expressions to get a single true or false. Right? Other things we can do, we can put if statements inside of other if statements. So let's ask someone what their age is. What's your age? And we'll get an int for age. Most people don't give you decimals, so I think integer is probably fine for age, right? I guess a double, but we'll just do integers. Parse int of the keyboard.next line. Right, and then we'll ask them, are you male or female? And we'll get that as a string value here. We'll have keyboard.next line. Okay, so now in our logic, when you go and buy car insurance, you get charged more if you're less than 25, I think it is, and you get charged more if you're male. So first we're going to check the age, right? So we'll say, hey, if age is less than or equal to 25, we know we're going to be paying more money. That's the first check here. And then inside of that, we can say, okay, if gender equals ignore case male, then you pay most for insurance. Right? If you're less than 25, but you're not male, right, our else case here, you pay more for insurance, but not the most. And then if you're over 25, where's our, so this ending curly brace, back it up a little bit, you pay the least for car insurance. I think after 25, they don't actually care anymore. They figure your brain's fully developed. It actually takes to your 25, which is crazy, for your brain to fully develop. You're less of an insurance risk, and they'll likely cost them less money, so you don't need to pay as much up front. Right, but you can put an if inside of an if. It's perfectly fine. Now, you don't always have to nest them, right? With our Boolean logic, we can put two things together. So instead of writing it nested, we have other options, right? So this is a nested if else. We could say, okay, if age is less than or equal to 25 and gender equals ignoring case male. In this case, then, you're paying the most for insurance, right? I'll just copy that line. But now our next else if, we need to check age again, right? So else if age is less than or equal to 25, right? So this first one is true if you're less than 25 or less, and you're male. The next one is true if you're less than or equal to 25, but because it's an if, else, they're mutually exclusive, you can't get here if this one was true, right? In the way that we're evaluating our expressions here, if you're less than or equal to 25 and you're male, we know you're going to get put in this block here and pay the most. So we're never even going to look at this, okay, are you just less than or equal to 25? Right, so they're paying more, but not the most. Then we could have the else here, the last case here. You pay the least. So depending on how many different cases we need to check, right? Maybe it's just as easy to do the Boolean logic versus nesting the if and else if. They both get the same job done. Right? So we have lots of different ways about solving our projects here. Generally, you want to avoid nesting more than a couple levels, just because like every time you nest, it's going to tab it in another set. See, like every time you have a set of curly braces, everything gets tabbed in underneath it to show it belongs to that block of code. And if you have an if and another if and another if and another if and another if, you're just going to run off the screen really quick. So, one or two nested, not too big of a deal. But if you're like got 4 or 5 nested levels, you've probably gone too far. And there's just probably an easier way to go about it. Right? Maybe not. Maybe you have to, because you've got so many different complex decisions that you have to make. But if we can avoid 5 levels deep, we're probably better off that way. Okay, we all right so far? So let's do. Did we do rock, paper, scissors already? Okay. We'll we're going to rewrite it real quick here. Rock, paper, scissors. And we'll get our string for the throw, or what the users throw, right? Keyboard.next line. Because there's another way you can write these if, else if chains called a switch. So if we've already done it before with if, else if, I probably don't need to do it again. Okay, it's not bad. So if users throw equals, so if they throw rock, what are we going to throw? What is the computer? What do we want to play as the computer? Paper. So if the user throws rock, they lose, right? Because we're paper. Let me grab this one. Right. Else if it is paper, then we tie, right? And else if it's scissors, they win. Okay, so pretty quick checking. Oh, I got too many parentheses here. Look at that. My copy paste was bad. All right, that looks a little nicer. But we could do it this way. Now, the other option that you have, if you have just a bunch of, hey, does it match this, or 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 does it match this? So you can use something called a switch. So in Java, you use the switch word, and then in parentheses, you say, okay, what are we comparing? So we're going to switch off of, or we're going to compare the user's throw. Then we give it a set of curly braces. All of our checking is going to happen inside of this set of curly braces now. And what we do is we give it cases. We say case, which is essentially, does it match this? We'll say case rock, and then a colon. The syntax is weird. I really don't like switches. You lose. So this is saying, okay, we're going to check on the user's throw. If it matches rock, this happens. Then we got to add this fun little special keyword called break. Break means switch is done, bail to the end, right? Stop doing it, what you're doing, go to the end of the switch, which is the ending curly brace. I hate breaks. Honestly, they're just hard to follow sometimes. I don't know, I get confused easily. So it's if you confuse somebody, then maybe you could do better with your code. So you might notice, though, that this case here is just rock all lowercase. Right? What if the user typed an uppercase R for rock, or an all uppercase, because they like to shout at people online, right? And they always have their caps lock key on. Two options. The first option that is probably not ideal is you can have multiple cases. So as soon as a case matches, the code runs until it finds a break. Now this is okay for all uppercase and all lowercase, but what if they just had a capital R, or they had random capital letters, because who knows why? You don't want to have to do every single case, right? So this is not ideal, right? That's too slow to try and match every possible option of casing. So what you can do instead is when you go to switch off of their throw, we've got some options. We can say, hey, user's throw dot to lowercase. And this dot to lowercase is going to say, hey, whatever this string is, make every character lowercase. So now all my cases can be done in lowercase, and it will match. So I don't need to worry about uppercase or lowercase. I said, hey, force whatever they typed into lowercase. Here with this option. So this is a little bit nicer. Right? And then we can do the rest of our cases. We can have case for paper, and we tie for paper. And then we have to break. We might even have an else here and say that's not rock, paper, or scissors. Right? Just be confused here. So if it doesn't match one of the other ones, we could say that. Sure. And then we could have a case for paper. Nope, scissors. Scissors. And if scissors, they win. And then we have to break. Now, to have this last else here, right, this is the default here, right? If it's not this, it's not this, it's not this, it's not this, it's not this. All right, if it didn't match anything, here's what you get. Kind of the default case. It's called default with switches. So we say default, and we can tell them that's not rock, paper, scissors, and be a little confused. Now, this last line here is the end of the switch. So you don't need to use a break because we've gotten to the last line. The very next thing is the ending curly brace. So after a default case, you don't break, right? Because it has to be the last thing. Right? So defaults must be last. Just like our last else has to be the last thing, because you can't have any ifs after that. Right? It has to be the last thing. So our default case must be the last one. Now, sure, if you like switches, great. Go for it. I tend to never use them. Just that, you know, they've got like weird colons in here. You have to use this break keyword. I think it's just easier to use the if, else if, else if, else ifs. But some people like switches, so go for it. Now, any switch can be replaced with if, else if, else if, else ifs. But not all if, else if, else ifs, else ifs can be replaced with a switch. Because a switch only matches on cases. So individual cases. So if we were to have an example like calculating your letter grade, if we said enter your score 1 to 100, then we had the int for the score was integer.parseInt of the keyboard.next line. And hey, we should even do a validation loop, right? We did one of these 1 to 100s before. We could repeat that, right? Right, we could do that. Said 1 to 100, enter a score between 1 to 100. And we're going to check score, score, and score here, right? We can keep on going. Now, you might think and feel a little bit bad that we have the same prompt and assignment more than once, right? I've got it here, and essentially it's here again, right? And anytime you have the same code twice, you should feel bad about yourself. So that's a good thing if you're feeling bad about it. So what we could do instead is we could make sure that the loop runs first. So that we prompt them. Now, they might get a little upset if we're telling them they're a dummy, so maybe we'll stop being a little snarky here, and we'll just say enter a score between 1 and 100. So we take out our prompt, and all we need to do is we need to set score at something that will make sure that this is true. We need to set score like 0, right? 0 is less than 1, the loop will run, and we'll ask him to enter the score. So instead of prompting, assigning, and then checking and validating, prompting, assigning, over and over and over, you can just set it to something invalid and let the loop run. Generally, this is a little nicer, right? Just a little bit less typing here. So this forces the validation loop to run at least once. Right, with this method? Right, and then we were going to check. So we could say, okay, if my score was greater than or equal to 94, and then if we wanted to, we could even get fancy here. We can say, and the score is less than or equal to 100. Right? So if you're between 94 and 100, you get an A. Now, with this, we don't need else ifs, else if, else if, else ifs, else ifs, because we can just do all of our logic this way. Now, that's more typing, so you can bet I'm not a fan. But you could, if you wanted to just have standalone ifs, right? If so, then is score greater than or equal to 90, and score is less than or equal to 93. You get an A minus. Right? Both will work perfectly fine. Right? Instead of it being an else if. So, again, I think that's more typing to have to do all these ands, and then the more often you have to type numbers in, the more likely you are to typo it. So, like, I might accidentally have the wrong number in here and be the wrong range, and then it's possible if you were at 94 and I wasn't paying enough attention, and I did 94 again, that it would say, hey, you get an A and you get an A minus, and then you'd be really confused, right? So generally, if we want one and only one to run, we want them to all be the else ifs here, right? And then you don't need to worry about all that extra logic. We need to say that one, because we know you can't be greater than 90 and get the A minus if you were greater than or equal to 94. Right? It's never going to check this if you were greater than or equal to 94. Because one and only one of these will run, and the rest of that chain is skipped. So being able to use the else ifs, we're kind of getting that first check for free, which is nice. Right? And this sort of chain here, so greater than or equal to 87, right, you get a B plus, on and on and on. We can't do this with a switch. Okay, technically you could. You could have case 100, case 99, case 98, case 97, case 95, case 94. You get an A. You don't want to do that as a switch. And then if we were doing something with bigger ranges, say like checking numbers in the size of 1,000,000 for whatever reason, I don't know why, but just imagine something, we needed to check numbers in 1,000,000. You're not going to write 1,000,000 different cases. Right? Nobody's going to do that. So not all if, else if, else ifs can be replaced by a switch. Right. That's the whole moral of that story. You can switch off of strings. You can switch off of numeric values. Doubles don't work well, just as you can kind of imagine, because you can have so many different decimal places. Like, is it 1.01, 1.011, 1.00001, 1.00012? Like, you're going to have so many cases that you're going to be confused. So typically we only switch off of strings, ints, or maybe even a character, like a single character at a time if you want. But you can do it. And the other reason switches are obnoxious, maybe, if you forget the break keyword, it keeps running until it finds a break. So it ignores the other cases and just keeps running the statements, which is super confusing. So if I don't have breaks here, because I forgot to write them, and I'm matched on rock, it's going to run you lose, it's going to run you tie, it's going to run you win, and then it finds a break and stops. If it doesn't match on rock, but it matches on paper, it'll run tie, you win, and break. If it doesn't match on rock, doesn't match on paper, but matches on scissors, you get you win and break. So it runs, as soon as it finds a case that matches, it runs until it hits a break. It runs every line of code, regardless of the other matches, which just makes it easier to screw up if you forget one of your breaks. Just another reason to think switches are awful. All right, the book has some other fun examples if you want to do more switches here with their little invoice application. Right, we did our while loop. Okay. The other option with this while loop, if we know we want it to run at least one time, you can use a loop called a do loop. Now, again, I have strong opinions about do loops because I'm weird and I hate them. But a while loop is considered a pre-test loop. It's going to test this expression first, and it could never run. Right? Depending on what the user enters or whatever values we're using, the loop may or may not run ever. Which probably okay, right? We only want it to run while it's true. So a do loop will run at least one time and then we'll check. So it's considered a post-test loop. So we could do that same sort of validation with it. So we could say, let's do int another score. Actually, here, let's write it first. We'll do it, say do, and we'll prompt here, enter another score, 1 to 100. We'll have an int for another score is integer to parse int of the keyboard.next line. Then with the do syntax, after the closing curly brace, you put in your while. You say, okay, this should keep running, again, while what is true. So when we say while another score is less than 1 or another score is greater than 100. Now, the reason I hate do loops is because you put a semicolon here. That's literally the reason I hate them. No other time do you put a semicolon at the end of a loop statement, other than with do's. I don't know why the fine folks who wrote Java did this. It irritates me. So I will go at great lengths to not use them, just to avoid this little semicolon here. And now it's upset with me. It says, cannot find symbol, variable, another score. Remember, anything that's defined inside a set of curly braces can only be used inside that set of curly braces. If I make a variable in here, like for int some number, and I give it a value, I can't use it outside. Like plus equals 10 or something. It doesn't exist. So there's this idea that the term for that is the scope, the variable scope. It only exists inside the set of curly braces in which you declared it. So if you want to be checking on some number, you still have to do You have to declare the value int another score. And then it's mad in here because we don't need to tell it it's an int again. Now, you do get to save the step of assigning it the value. It is smart enough to know, hey, you want an integer called another score. We're not going to give it a value yet. We can declare and we can assign it a value later. It can get assigned a value inside the loop. Fine, like we didn't have to start it off as an invalid value like we did with our while loops, right? We had to say, hey, this will force the loop to run at least once. Give it a value that is invalid to make the loop run. In this case, sure, we just need an integer. I'm going to go set it. If it's invalid, right, keep on running. Right? As long as it's invalid, keep on running. Sure, no big deal. So that's the do loop, and do is a post-test loop. Runs at least one time. Now, the other reason I hate the semicolon is you can actually put this at the end of a while loop. If you put it at the end of a while loop, it's an infinite loop. It will run forever because it says, oh, your command is do nothing. Check again. Is it still true? Yep. Okay, do nothing. Is it still true? Okay, do nothing. Is it still true? Okay, do nothing. It actually never gets to what's inside the set of curly braces because you put the semicolon here. So it's really, really obnoxious. Now remember, the book said if you want, you could have an if statement without a set of curly braces. This is terribly bad form. Really, really bad form. Technically, it'll work because the very next line of code after an if is automatically attached to the if or belongs to that if statement. But if you try and do another line of code, that's the answer. This is not attached, and it's warning us. We're getting these yellow lines. It says confusing indentation. So it shouldn't be indented this far in because it doesn't actually belong to the if statement here. So just because we tabbed it in doesn't mean it's going to run if this is true. Did I tell you about the Safari bug from years and years and years ago? All right, back when I was in high school, that's how long ago this was, the fine folks at Apple had an issue with Safari that made it so the HTTPS, the secure connections, weren't actually secure. And it boiled down to one of their developers had an if statement without curly braces. And the second line of code was always running in certain situations, breaking the security because they didn't use curly braces. Right, so just always, always, always use curly braces. Right? That is the right thing to do. Technically, they're not required, sure. And if you go somewhere and they write your paycheck and they say, we don't need curly braces for one-liners after an if statement, just smile and nod. Right? They're writing your paycheck, not me. Don't be like, oh no, Professor Eric said I should always use them and I'm going to die on this hill. It's really not worth it. Okay, I'll get up on my soapbox and complain about it, but right, if the convention at your organization is we don't, then sure, smile and nod. Right, it's not that big of a deal, but just usually safer here, and that's technically why that semicolon works with a while. It does the same thing. A single line of code after a while statement is automatically attached there. And if we had an if with a semicolon, it'd say, oh, sure, that empty command, just do nothing, is attached as well. Like you could put a semicolon after the if too. Really bad, because it's going to do nothing if that's true. And then this code will always run. It's just awkward. Okay? All right, so that's a do while loop. All right. All right. Now, you can put an if inside of an if, right? You can put a loop inside of a loop. Right, so let's go through and let's print, just for fun, all the possible times on a clock. Again, very contrived example, but this will be easy enough for us to do. So we'll say here, int hour is 0, and we're going to say while hour is less than or equal to 23, because we're going to use the 24-hour clock. We want to do something. Right? So for every hour, we want to reset, we want to start int for minute, starts at 0. And while minute is less than or equal to 59, let's do something. Right, so for every hour, we're going to do this, we're going to start minute, and we're going to loop for every minute of every hour. Right, should we do seconds, or is that enough? Just hours and minutes? All right, we'll just do hours and minutes. Excuse me. So we'll print out hour plus a colon plus the minute. Had a tickle in my throat all of a sudden. Right. Now, if we're not changing this value here, we've got an infinite loop. So right now it's an infinite loop because we're not changing anything. So print it, and then we'll take minute plus plus, right, add 1 to minute. When this loop is done, right, when minute is no longer less than or equal to 59, when a minute gets to 60, we're done with the inner loop. And this will end. Then we'll get to hour plus plus. We'll add 1 to hour. We'll go back and check. Hey, is hour less than or equal to 23? If it is, go inside the loop, reset minute to 0. As long as minute is less than or equal to 59, let's print again. Right, and we probably want this formatted nicely. It would be nice to have like 2-digit numbers here. I don't think we've done a whole lot of formatting yet. If I were to show you, it wouldn't make a whole lot of sense. So it's going to look a little bit funny at first, instead of being like nicely formatted 2 digits and 2 digits. We can fix that later when we learn a little bit more about it. Sorry. Oh. Let's give it a shot. See if we can print out every hour and every minute possibility here with the loop inside of a loop. Blue, 42, blue, 5. Can't pay the most. Rock, paper, scissors. Rock, 2, 42. It didn't even do it. This compile on save setting gets me every time. I don't know why. It's not helpful at all. I wish I could just turn it off, like, as a default. All right, let's try one more time. Run it. Right, now it's actually going and building. All right, 42, blue, 42, blue, 5, rock, 42, 42. There we go. Now we get all of our possible times. Look at that, all the way from 0, 1 to 59, right? 0, 0, right at midnight, 0:59, 1 o'clock in the morning, on and on and on. Not super interesting, but it's a loop inside of a loop. And you notice this actually took a little bit of time to print out on the screen. I don't know if you saw it, like it lagged for like half a second. Printing things to the screen in terms of speed is one of the slowest things you can do. So if we're going to loop through and then we're going to print like 100,000 things to our screen, it's going to take a decent amount of time. If we just want Java to like calculate something 100,000 times, it'll do it like that. But the act of printing is going to slow it down a lot. Because that's just a slow operation. All right, awesome. We're doing pretty good. So we got loops inside of loops. We got some other ones to tackle here in a little bit. Where's the other? I think I skipped that one. There you go. There's another kind of loop. Why don't we take a break before we start talking about that? We've been talking for almost an hour now. I gotta go grab some Coke, figure out what's tickling in my throat here. We'll pick it back up in about 10 minutes or so. That sound good? All right, we put a break screen on here. We'll pick it back up. What does that put us at? 11:06 a.m. All right, we're going to have a little bit more fun with loops. We're going to save some more of it for Monday. Again, not quite as much on Monday because we got to go over the project, although that shouldn't take too long to figure out how many pies we need to order. I wish we could actually have real pie, but again, the Ridgewood Cafe I think will be open. That's the first Monday they'll be open for grab and go lunch. They usually have some really good stuff there. I'm not hungry or anything, you know. Don't worry. I'll get some food at some point. All right, so we did our do loops. We did the while loops. So the other kind of loop that you can use is called a for loop. And now for loops have some crazy syntax that are going to take a little bit of getting used to, but they're super useful. Right? So with a for loop, you say for, and then you have 3 sections here. So let's see, we did, let's maybe do a while loop first. So we'll do, before we do that, we'll say while, here's an int, number is 0. We'll say while number is less than 10, we'll print out number plus plus. Right? Number plus plus means I'm going to take the number first, and then I'll add to it. So I'm going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once it prints out 9, it adds 1 to it, becomes 10. It's no longer less than 10, the loop will stop. Okay? So with the for loop, what it lets us do is inside of the parentheses, we have to give it 3 different things. We give it an initialization, which is essentially this line here. We give it the test, which is this line here. And we give it the update, which is this portion here. So we give it 3 sections separated by semicolons. It's awful until you get used to it. So we'll say int another number starts at 0, and then, so this is initializing. So we're saying, hey, start my loop, create this value. Then we'll say, okay, as long as another number is less than 10, we want the loop to run. And then we'll do another number plus plus for our update. Now, the general rule when it comes to for loops is the value that's up here, you don't use inside the loop, or at least you don't change inside the loop. You can, but again, it's one of those things that just gets really confusing. So like this should be the only place where that value changes in this update line. And in here we would just print out the another number. It's going to do the exact same thing as this while loop, right? We declared the value, we declared the value. We looped as long as this is true. We looped as long as it's true. Now, in this case, the update was like part of the print. That's just one of the cool things with this plus plus command. The other way we could write that, right, we could print it and then take number plus plus, right, to make it separate if you wanted. Sure, they just saved one little line here. So we have our update here, and then the actual command. So for loops are fantastic if you know how many times you're supposed to loop, right? If I know, hey, I've got 25 people in class, I'm going to enter 25 test scores. I can loop 25 times and do the min, max, and average for the test scores like we've done, right? Versus the while loop was like, hey, keep on entering test scores, or, you know, do you have more? Yes. 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 That sort of thing. So while loops, if we don't know how many times they're going to run, much better, because you can't really do that with a for loop. Technically, you can. Each one of these three sections is technically optional. It's awful. Don't do it. Right? If you're going to leave one of those out, just use a while loop. Right? They're essentially interchangeable, because this is the condition to run if it's true. You don't have to initialize. You don't have to update. So really, any while loop could be a for loop. Any for loop could be a while loop. But we tend to use the for loops if we know how many times we're going to run, and we tend to use the while loops otherwise. So to do that same number countdown thing, we could do that with for loops. We could say for int hour 0, hour is less than 24, hour plus plus. Oh my goodness, plus plus. There we go. And then inside of that, we'd loop again. We'd say for int minute is 0, minute is less than 60, minute plus plus. So it's upset because I've already declared hour. So you can just set a value here instead of declaring a brand new one. Usually that's bad form. So I'm going to have, like, I'll just call this another hour, I guess. I'll do another hour every time. Now, minute is not upset about, right? Because minute was declared inside of this loop. So after this closing curly brace, the rest of our code has no idea that minute exists, right? Because it was declared inside a set of curly braces. It only exists inside of those curly braces. So it's fine with minute here again. We'd print out hour plus a colon plus the minute, right? Exact same thing. And a little bit less code here, right? And we don't have to worry about doing the updates each time. And honestly, I've forgotten to do these updates before, and then I have an infinite loop when I run my code. And I'm like, oh, I forgot to change it. So by forcing you to put the update in, this is called the loop header. It's just another way of making sure we're only going to run it so many times and not be stuck in an infinite loop. It works out pretty well. It doesn't mean you can't do other bugs. Like if we did something wrong with our condition and did it the wrong direction or set it to a bad value, we could still be infinite with a for loop. It would just be a little bit harder for us to do that. Right, if I said this was like greater than 24, this would actually never run. This would I start at 0, right? So I'd have that problem if I typo my greater than or my less than. Right, so that'll do the same thing here. So let's have a little bit of fun with some for loops. Do you guys ever heard of ASCII art? Maybe like you draw shapes with characters. We're not going to do anything pretty here, but we're going to have a little bit of fun with some basic shapes. Like, how about a square, right? If I do 5 stars in a row 5 times, I know it's not actually square looking, because like my rows aren't quite the same as my width, but it's pretend, okay? Just pretend with me. Call that a square instead of a rectangle. Are we okay with that? So how could we print a square of any given size, right? Let's ask the user. We'll say, hey, how large of a, or I don't know, what size square should we print? How about that? What size do you want to print? Now we'll have an int for size. Square size is integer.parseInt of the keyboard.next line. Right, so given some sort of a value here, how do I print out a square? Right? Say the value is 5. What do I have to do first?
X amount on a line and then go down to the next one?
Yeah, I have to print that many stars. Okay, so I need to do something for so many rows. So I'll say for int row is, we'll start at 1. Row is less than or equal to square size. Row plus plus. Right, so for every row in size, I need to do something. Right, the thing I need to do is print that many stars. Right, so it's another loop. It's a loop inside of a loop. We'll say for int star is 1, star is less than or equal to the square size, star plus plus, and we'll print. Now, we want to print, not print line. Remember, print doesn't go down a line, where print line puts in the new line character and goes down a line. So if we just print a star character, we're going to get all of our stars on the same line. Sorry, I can scroll that up a little bit, sorry. So we'll get as many as our size is, number of stars. Now again, if you like 0 and less than's, great. If you like 1 and less than or equal to's, great. The number of repetitions here is the same. Some people don't like starting at 0 and going less than. So either way will work for you. Once I've printed out all the stars that I need to print, right, and the inner loop is done, then I want to print a new line character and go down a line, go to the next row. So for every row, print all the stars, go down a line. Next row, print all the stars, go down a line. Next row, print all the stars, go down a line. Over and over and over, right? Okay, let's try it. You know, we have a bunch of prompts there. Let me, just for now, I'm going to put this up at the top. I'll put it down at the bottom later, so it's sort of kind of in order, but let me just leave a note. Let me back down. Right. That way I don't have to enter all the numbers and colors and whatnot here. Give that a shot. All right, so what size square do we want to print? I'll wait on you. Just somebody shot out a number.
We used 5 by 5 earlier. Let's just do that again.
5. All right. So 5 stars, 5 stars, 5 stars, 5 stars, 5 stars. Looks pretty good. Should we try it again with a different number? Just to make sure? Right. 7. 1, 2, 3, 4, 5, 6, 7 rows. Looks like 1, 2, 3, 4, 5, 6, 7 stars. All right, awesome. We got 7 by 7. Okay, feeling pretty good about that. Now, what if we wanted to do a rectangle? Right, have so many rows and so wide. Can we do a rectangle? Sure. So let's ask them. What? How about height? Rectangle. What do you want? I'll have an int for rectangle height. Integer.parseInt. The keyboard.next line. Okay, so we'll have a height, and then we need the width, right? What width rectangle do you want? So rectangle width is, and I'll just copy paste this. Don't need to bother typing again. All right, so same idea, right? So for every row, we're going to do something, right? So for every row in the height, as long as we're less than or equal to the height, let's go do something, right? And then how many stars do we print? Well, we need to print the width number of stars. Right? So as long as we go less than or equal to the width, we'll print that many stars. When we're done with the width, right? When we're done with that row of stars, go down to the next row. And then go down to the next row. Print that many stars. Go down to the next row. Print that many stars. Right? So we should be able to go any width and any height. Should we try it? Oh, am I still running? Yep, still running. I gotta stop that before I can hit run again. All right, so sure. A 1, sure. That's our square. How about rectangle? What height rectangle should we try?
10.
10? All right, and what width?
4.
4. All right, looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows of 4 stars. We have a nice little rectangle. All right, that one's pretty straightforward. How about a triangle, right? Something like that. Can we do one of these? Yeah. All right, so let's ask him for a triangle. We'll say, what size triangle do you want? What size triangle do you want? And this will be our triangle size. Sure. So again, we're going to, for every row, we're going to do something, right? For every row that's less than the triangle size, we want to do something. But what do we do for stars? How many stars do we need to print each time?
Start at 1 and then add 1 each time.
Yeah, so at row 1, we print 1 star. At row 2, we print 2 stars. So we should print the row number worth of stars. So our stars will check to see that we are less than or equal to the row number. So again, we're not changing row, so it's okay to use this value in the rest of the loop. Just don't change it here. So we're saying, okay, as long as we're less than or equal to row, print that many stars. So as row increases, stars will increase. Let's give that a shot. See if we can get a nice little looking triangle. 1, 1, 1. All right, triangle. What size triangle do we want? 6. All right, 1, 2, 3, 4, 5, 6. Look at that. We got a nice little 6-sized triangle.
Go back.
To yeah, yep.
Why'd you put less than?
Because we're starting at 1, and we're going as long as we are equal to less than or equal to the number of rows. So as row increases, right, we want to increase. Yep.
Wouldn't it just be equal to?
No, because when row is like at the 5th row, we say, okay, we've gotten to row 5. Start at star 1. Is 1 less than 5? Yep, print 1 star. 2 is 2 less than 5? Yep, print the 2nd star. Is 3 less than 5? Print the 3rd star. Print the 4th star. Print the 5th star. Star would then turn to 6. 6 is no longer less than 5. And then we'll stop printing stars. We'll print the new line. Go down to the next row. Okay? So let's do one more for practice here. This one will be a little more interesting. How about an equilateral triangle? So instead of it being this left aligned to right triangle, why don't we do something like star, 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 star. Let me do 2 more rows here then, right? Like an equilateral triangle. Right, can we do something like this? Now, a couple things to note here is this width has to be odd because we're decreasing by 2 each time, right? This was 1, 3, 5, 7, 9, 11. This is 11 stars. This is 9 stars, 7 stars, 5 stars, 3 stars, 1 star, right? So we need to make sure we start at an odd width here. So do you know how we could check for an odd number? Right, what determines if a number is odd or even? If it's evenly divisible by 2, right? Any number can be divided by 2, right? 3 divided by 2 is 1.5. So if it's evenly divisible by 2, so do you know any way that checks to see if something's evenly divisible? Right? We had some sort of division operator that would give us a remainder. A modulus. So modulus 2, if you're evenly divisible by 2, what's the remainder? 0. So if your size mod 2 is 0, you're an even number. If you're an even number, you're no good. Let's make you odd. Right? Even number, any even number plus 1 will turn into an odd number. So this is making sure it's an odd size or an odd width, right? Sure. Well, we can use the same triangle size. We don't, I'm going to do another like print line here just to separate them a little bit here because we're not doing another prompt. So if we have an odd size, now the other bit here though, can you just print a star in the middle of the screen? Nope. So you have to print some spaces, right? So how many spaces do we have to print here? Well, it's 1, 2, 3, 4, 5 spaces. Okay, sure, I counted, I know it's 5. But how would I know, based on the width of a triangle, how many spaces it needs? I don't know. Let's go back to math class here. Right? Pull up our whiteboard here. So if we have, say, a width of 3 here. So if we make a little chart here, if we have width and we have spaces. With a width of 3, how many spaces do we have? That's one space there, right? With a max width of 5, there's one space on that line, there's 2 spaces on this line. With a width of 5, it's 2 spaces, right? With a width of 7, I can't even write that many stars, right? We have 1 on that line, 2 on this line, 3 on this line. Right? Do we see any sort of relationship going here? So if we had 9 width, what do you think the number of spaces would be? 4, okay, sure. So how can we get from this number to that number? What kind of math can we do? Right, what's our formula for it? To take width and turn it into number of spaces. What do you think?
Like you take the width and minus it by the amount of like it's been going to -1.
Well, so that's as we go, but how do we get from the width to the first number of spaces? So if I have a width of 9, how do I know that I need 4 spaces? What math is that? Because we have to print the first row, right? We can't print a row and then print a line above it. We have to print from the top down as we print.
First subtract 1 because there's always the 1 star in the middle and then divide by 2.
Sure, so width minus 1 divided by 2. Now, the other cool thing, because width is an integer, if you divide by 2, what happens to that half? It's gone. Integer division. Right? You lose any decimal remainder. So you don't even need to subtract 1. Right? Because 3 divided by 2, 1.5. But as an integer, that's 1. Right? If you get rid of the half. 5 divided by 2, 2.5. You get rid of the half. It's just 2. Right? So we take our width divided by 2 each time to find a number of spaces. So we have spaces is going to be our triangle size divided by 2. And this, integer division is good here. Right? We want that to happen. Okay, cool. And now we're going to loop, right? So we'll say for int, now row might be a little bit funny here, right? So I think it might be easier if we say this is the star, right? Because the first row gets 1 star, right? So I'm sorry, let me slide that up. So we'll start with star at 1, and now we want to keep going until we have how many stars? Stars should be less than or equal to the triangle size, right? The number we're going for, so triangle size. And now we don't want to increase star by 1 each time, right? How many new stars do we get every row? 2. So we'll take star plus equals 2 every time. That's our update. We'll add 2 stars every time. So then what do we need to do? Well, we need to print our spaces. So for int space is 1, space is less than or equal to spaces, using the plural here, sure. Space plus plus. Now we print a space. So print, not print line, the space character. This will print out the right number of spaces. Right? Then we need to print out the number of stars. So we do another loop. So for int, actually this should be stars here, sorry, stars. So for singular star starts at 1, right? As long as it is less than the total number of stars, we'll add 1 at a time. We'll print a star character. Right? So if the first row gets 1 star, we'll print 1 star, the loop is done. We come back up, we've added 2 now. We need to print 3 stars. Stars 1, print. Stars 2, print. Stars 3, print. Great, we get 3 stars. The only thing we're missing now is changing the number of spaces. Remember, each time, what happened? We had 1 less space, right, as we went. So in the loop here, then we can take these spaces, take it down by 1 to decrease the number of spaces. Let's try it. Should we try an even number? Make sure it turns into an odd number? All right, what size triangle should we go for? 16. All right, let's do 16. So here is our right triangle. We did not do our new lines. We forgot new lines. That's okay. Right? Take our spaces down by 1 and then just print out a new line to make that whole row go down a line. Let's try that one more time. $16. Oh, we're close. Close, not quite here. Let's see what happened. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Looks like it didn't get changed. So we started with that odd number, or an even number. All right, let's see what happened. Oh, triangle size. Mod 2 should have gone up by 1. Why did it not? Oh, less than or equal to stars. Nope, so the number was fine, but I was not printing enough stars, right? Because when we need 1 star, we want it to print 1 time. This was saying when we needed 1 star, star is not 1 is not less than 1, and we didn't print any. Little typo there, sorry. Let's try one more time. I think we're on the right track. 1, 1, 1. All right, 16. There we go. So 1, 3, 5, 7, 9, 11, 13, 15, 17 for an equilateral triangle. So in my check here, I was saying star was less than the number of stars. So if I needed 1 star, when star started at 1, 1 is not less than 1, I wasn't printing 1 star. And if when star was 3, I printed 1 is less than 3, 2 is less than 3, but I didn't print the 3rd star. So I was always 1 short on all the stars. So the number got updated to odd correctly, but the number of stars I was printing was wrong, because we stopped before we got to the number we wanted. Okay, so we can have some fun with some shapes. Loops inside of loops. I think that's probably enough practice for now. We're almost done. We'll save some for next week. We got a couple more things to cover from Chapter 4, and then we'll also cover Project 1, and then we'll talk about the next project as well. All right, so we'll cover the solution to Project 1, we'll finish Chapter 4, we'll talk about Project 2 come Monday. And then we'll also post the quiz for Chapter 4. Okay? You feeling all right? Again, it's new syntax. It's going to take some practice. I'm trying to give you examples. The book will give you more examples. You can go and play with it. At the end of the chapter, the Murrock has a bunch of practice problems. Like, they're actually pretty handy to go out and practice and try some, and try and do some more things. And we can go from there. All right. Awesome. Thanks, folks. We got the rest of today to hang out and work on whatever you want. Maybe finish up Project 1. So that you don't email me 3 hours before it's due and say, oh, something came up, can I have an extension? Like my Tuesday class did. Let's not do that, please.